We performed a verification test to determine the functionality of our device. The specific device input we tested was whether or not our device could reduce saliva spillage by 80%. We did so by building a mouth model to simulate patient drooling and accurately test the effects of our device's suction. The materials used for testing consisted of our vacuum device, a mouth model, a saliva replicant consisting of 99% water and 1% honey, a test rig structure, and injection and measurement tools. Our mouth model was constructed from a dental retainer case with Play-Doh molded around the front to simulate the lips. The test stand consisted of a wooden block. Below and in front, we set up a collection reservoir and a food scale to measure liquid spillage. Our goal was to simulate the patient's positioning with our testing setup. Because the majority of saliva spillage occurs when our patient's head is tilted downwards approximately 45 degrees, we replicated this tilt angle by attaching our mouth model to a hinge. Additionally, the elevation of our mouth model reflects the distance between the intended attachment point of our device, which is about level with the armrest, and the patient's mouth, which is a distance of approximately 18 inches. We wanted to ensure there would be no problems with our tubing or suction power despite the difference in height.
Using the mouth model setup we've created, we first decided to test the control, which would give a baseline of how much water spills out without the device. From this video, you can see that the case is first filled in order to mimic patient drool spillage after his mouth is full of saliva. Around 0.7 milliliters of water was injected through the retainer case evenly over the course of a minute. This rate is derived from a literature value that states the average person can swallow up to 1,000 milliliters of saliva a day. Afterwards, the amount of water that dripped out was collected and measured using a syringe. When testing the device, the mouth model was set up in the same way. Additionally, the device was turned on and placed near the mouth opening. To prevent possible safety hazards of suctioning inside the mouth, this position was chosen. Around 0.7 milliliters of water was injected at the same rate through the full retainer case with the device positioned and turned on. From this video, you can see that no amount of water dripped out. All water was suctioned by the device.
The acceptance criteria for a device was whether or not it could reduce saliva spillage by 80% or more. The raw data from our trials is shown. With our device on, all the saliva spilling out of the model was collected by our device, meaning 0 milliliters of saliva spilled into the reservoir. With the device off, an average of 0.75 milliliters of saliva spilled into the reservoir per trial. These box plots represent the data. Visually, we can see that there is no variability in the experimental plot, indicating that 0 milliliters of spillage is expected for further repeated trials. This suggests that with our testing procedure, the expected reduction in spillage is 100%. To quantify the difference between saliva spillage in our device on and off, we also ran a paired t-test. The p-value of 0.0015 suggests that operating our device has a significant difference in saliva spillage compared to the control. Based on our box plot and t-test, we conclude that our device passes our acceptance criteria and meets functional requirements.